Okay, so today we're going to work kind of like solving equations that have those parentheses in them, like we did yesterday. One of our learning goals yesterday was being able to solve equations that have to have distributive property used to simplify them first. So today we're still talking about problems that look like you could use distributive property for them, but instead we're going to use the reciprocal of that multiplier today. Instead of multiplying that, taking that and distributing it to the addition problem inside the parentheses, we're going to use the reciprocal of that multiplier to help us get ready to solve. Actually, we'll be diving right into solving the equations. So there are options, in other words. When we're solving these equations, we have another option, and so let's check that option out, see if you like it better, or sometimes it's kind of like, you know what? It's sure a good thing there is this option because then I can use it when I don't know what else to do. Okay, so you can choose to multiply by the reciprocal instead of doing distributive property. That's our whole goal today. So give me an example of some reciprocals. What are we talking about when we're talking about reciprocals? Dan, you give me an example. Okay, she says 1/3 and 3/1 are reciprocals. Do we agree, class?
Yes.
Okay, wait.
1x.
1x and oh, what is the definition of a reciprocal? Does anybody kind of remember what that's? Carly? Yeah, so that's kind of how we get it, don't we? We take a fraction and we flip it. And the flip is the reciprocal of that fraction that you flip. Does anybody remember what's supposed to happen when you multiply reciprocals? You better get a 1. So if we took 1/3 times Danny's 3/1, is 1/3 of 3 1? If I have $3 and I'll give you 1/3 of it, how much will I give you? $1. Okay. Give me another pair of reciprocals then. That if we multiply those two numbers, we would get 1. Wait.
1/2 and 2 over.
Okay, 1/2 and 2, or 2/1. 1/2 and 2 are reciprocals, and we can make 2 into a fraction by putting it over 1, so those two multiplied would give us 1. Okay, how about what's the reciprocal of -3? What's the reciprocal of -3? +3? I think that's a different definition. What +3 and -3 have what relationship? +3 and -3 are related how?
They're another word that starts with
They're not. They're a word that starts with no. They make 0 pairs, which makes them opposites. Yeah, they're opposites. So -3 and 3 are not reciprocals, they're opposites. So what is the reciprocal of -3? What would I have to multiply -3 by? I'm just going to put it up here. You don't need to put this on your notes, but I just wanted it staring us in the face. What would we have to multiply that by so that when we got done, we would have +1? What do you think? Sam? -1/3, Sam says. What do you guys think? -1/3. Because if I make this into a fraction, what's a negative times a negative, class?
Positive.
A positive. And 3 times 1 is?
3.
3. And 1 times 3 is?
3.
3. And 3/3 is?
1.
Hi, I think Sam has it. Okay, so when we have a negative number, its reciprocal is also going to be negative. It also has to be negative. We flip it, but we also keep the sign, don't we? Okay? So we have to make sure that we understand reciprocals well enough to be able to use them. So let's look at our first equation here. We have 2 times a -x subtract 4 equals 16. Well, what's Lagrange going to expect you to do first? Add the opposite. So before you do anything else, you are going to change this subtraction problem into an addition problem. What else could we slip in there that might make it kind of even friendlier to work with? A 1 in front of that x and between the x and the negative sign, right? Could we do that too? Okay, yesterday we learned that since negative 1x and negative 4 are not like terms, we can't put them together, can we? So we learned that, well, to get rid of the parentheses then, we're going to have to take that multiplier. What's the multiplier in this case? 2. We're going to have to take that multiplier and we're going to have to distribute it to get rid of the parentheses. Well, today I don't want us to do that. So if you've already started doing that, stop. So we're going to try a different method. We're going to multiply by the reciprocal of that multiplier. What's the reciprocal of our multiplier? Okay, maybe we better put that over here. Multiplier is maybe we should add that into our notes. The multiplier is 2. Today we're going to multiply by the reciprocal instead. So Danny, what would we multiply by? 1/2. You guys agree that the reciprocal of 2 is 1/2? So let's do this then. Here's how we'll show that. We will go on to the next line. Don't do it on that line. No. Move down. We got lots of white space here. 1/2 times 2 times that parenthesis with that negative 1x plus negative 4 in it. So we're just copying everything down. The only thing we did is we stuck a 1/2 times out front. And then if we do that on that side, we have to do it on the other side. So we're going to take 1/2 times the other side also. Okay. What happens when we take 1/2 times 2? We get 1. So it's like, here's what we're going to be able to do over here. If we multiply the multiplier by its reciprocal, we're going to be able to say, see you guys. And we're going to have, that helps us ditch the parentheses. We're going to have negative 1x plus negative 4. And then over on the other side, we're going to figure out what half of 16 is. What is half of 16? Did I hear it enough times to make it easy? 8. Okay, let's go with 8. Well, notice we've already been starting to solve here, haven't we? Because whenever we do something on both sides, we are solving. So let's continue solving. What should we do next? Add a positive 4 to both sides. It's that negative 4, that this negative 1x says, get out of here, negative 4. So we're going to say, okay, fine. I need a positive 4 with me to make a 0 pair. And now I should have these guys gone, right? They 0 pair each other out, and we have negative 1x equal to what? 12. Are we done?
No.
Oh, what do we have to do? We have to what? Divide by negative 1. Yeah, I thought I heard the word 2 in there, and I was like, I don't think we can divide 2 something. Divide by negative 1. I must have been writing kind of big. I ran out of space. So I'm going to come over here and say x now equals negative 12. A positive divided by a negative is a negative, and 12 divided by 1 is 12. Our solution is negative 12. Well, we always want to make sure we're right. Correct? Do we like to be right? Yeah. Okay, so what are we going to do? We're going to do a check problem. Well, the first thing we do is we write down, and I'll just let you take the new name we gave it after we changed it to add the opposite. So 2. So let's write the equation down in its friendlier form. What is this over here again? 16? Okay, thanks. Are we solving? Are we solving? Are we solving? No! We're what? We're checking. Seriously, folks. Good morning. Yeah. Okay, so here's what we do. In a check problem, we substitute negative 1 in front of x means multiply. So we're going to put that negative 12 in there. Would you? You've got to keep those parentheses there, but would you put a box around that substitution problem to make it stand out? So we replace the x with a negative 12. Everything else about the equation is going to stay the same. This is where if we want to make sure we have a good answer, we also want to make ssure we do a proper check problem. Okay, order of operations says what? What's first in order of operations? Well, no, long before that. Parentheses. And then when you have parentheses, inside those parentheses, you have to do what? Order of operations. So what would we do first inside those parentheses? Yeah, we would take that negative 1 times that negative 12. What is that? 12. Notice I didn't take the parenthesis away. We're performing order of operations within the parenthesis right now. So we have to finish our parenthesis in the next step, right? So now we'll combine our 12 and our negative 4. 8. I have $12. I give 4 of it away. I now have only $8. 2 next to parentheses 8 means what? Multiplication. So 2 times 8 is? 16. Bring down our equal sign, bring down our 16. Did it check?
Yes.
Yes, it checked. Okay. You are ready to move on. Okay, go to the back side and decide what are you going to do. What are you going to do with that problem?
Oh.
Anybody want to share their first move? Any subtraction in it? Okay, we don't have to rename it. So, does it appear ready to solve? No, it's not ready to solve. What do we have to do to it then? If it's not ready to solve, tell me what we got to do to it. Harley? So we're going to take 1/4 times 4 because we want to get rid of that 4. Oh, well, if we do that on that side, don't we have to do it on the other? And once we do something on both sides, what are we doing? Oh, now we are ready to solve. Oh, okay, then we're ready to solve. Oh, well, then we'll solve. Okay, Harley says over here, because there's a 4, the reciprocal of 4 is 1/4. So we're going to take 1/4 times 4 to get it to become a 1 so that we can get rid of it. Well, if we do that over there, we got to come over here and do it also, don't we? We can't just do it on one side. Well, we're kind of used to working from left to right, so it doesn't really matter, does it, which side the x is on? Have we ever decided that the x has to be in a certain place? No, I don't think we've ever made that decision. So, anybody know what 1/4 of 20 is? If I have $20 and I'll give you 1/4 of it, how much will I give you? $5, okay. And what happens here? What happens here? What's 1/4 times 4? 1. So this really becomes 1. And when you multiply something by 1, what does it do? Does it affect it? No, so it's kind of like, that's why we get to cross this out. Because it would be 1 times that x plus 1. And 1 times x plus 1 wouldn't affect it a bit. It would just still be x plus 1. Okay, now let's do the next step. What would the next step be? What do we do next, Tyler? Get the 1? No, get rid of the 1. The x doesn't want it then. What are we gonna add to get rid of it? -1, absolutely. We're gonna add a -1 because x says get out of here 1. We want these guys to 0 pair out. What's 5 plus a -1? 4. Is there another step to do? No. Because the multiplier in front of x is a what? A 1. That's kind of what we wanted to be, don't we? Okay. Now, well, let's just go ahead and check it, and then we're going to do one more thing, okay? So we have 20 equals 4 times x plus 1. What's up? What's the next thing we do? Starts with an S. Substitute. We say that x is equal to what? 4. Okay. So we just write the equation just as it is, only substituting 4 in for x. We're simplifying as we go down. We're not solving right now. So there's a set of parentheses there that has some like terms in it. We can put them together. What's 4 plus 1? 5. And 4 times 5 is 20. That's a good thing because that's what we wanted to be doing. Okay, now, before we call it quits, we're going to go off to the side because we got some white space over there. And we're going to solve it the way we learned yesterday and see if we get the same answer. Okay? So let's go over here and let's write our equation again. And let's show that, you know what? It doesn't matter which method you use. There still really only is one solution for this equation. And right now we think it's x equals 1, don't we? So let's see if we get it when we do what we did yesterday. Okay, we already decided we don't have to do any subtraction, changing subtraction to add the opposite. We decided there wasn't anything we could do to, get this equation ready. We said it was ready to solve, didn't we? So, 20 is 20. Yesterday we did distributive property. It's like that 4 has to be multiplied times both of those terms inside the parentheses. So this is what we did. We said take the 4 times the x, bring down the addition sign, and take the 4 times the 1. Okay, next step, you do it. Do those multiplications. Haley, I'm going to steal your answer. I stole Haley's answer. Do you guys have the same thing? It's really good information. Okay, now what? Harley.
Add -4.
Add a -4 to each side. Because that 4x says you guys need to get out of here. So now we have 4x alone. It's getting its way. And 20 plus -4 is 16. Oh, we didn't get x equals 1. I was like, hi, something's going wrong here. We got x equals 4. Why didn't you catch me on that? You guys. Okay, what are we going to do now? We're still not done. We got to divide both sides by 4 because the coefficient on x is 4. So now we're going to have x by itself, and 16 divided by 4 is 4. Well, hallelujah, we got the same answer as we did over there. We didn't get x equals 1, we got x equals 4, didn't we? Okay, so both methods work. If they ask you to use the reciprocal method, you now know how to do that. If they ask you to use the distributive property method, you know how to do that. Okay? Questions? Okay, can I quit this? Are we all caught up? Okay, so we're going to